Hello and welcome to my presentation. My name is Raghav and I'll be talking about the use of natural language processing in improving the value in healthcare. Before we delve into the topic of natural language processing, it is important to understand some major changes that have happened recently in the healthcare in the United States. The Institute of Medicine report from 1999 noted that medication errors were the fifth leading cause of death in the United States after diseases like cancer, heart attacks, etc., raising concerns about the quality and safety of healthcare in the US. Subsequent reports confirmed these observations and also noted that 30% of what is spent in healthcare is a waste due to duplication of work, administrative costs, etc., amounting to a shocking figure of $750 billion annually. A recurring recommendation from these reports was to implement electronic health records as one of the solutions to these problems. Another reason for the Institute of Medicine to advocate for electronic health records was to solve the problem of data siloing that happens with paper charts. Making patient care information entirely electronic facilitates real-time automated analyses and also allows for data reuse. This overarching concept is termed the learning healthcare system. Eventually, the HITECH Act was passed by the US government in 2009, mandating the use of electronic health records in all healthcare settings. Since the adoption of EHRs, the amount of digital data produced by healthcare has astronomically increased and is popularly known as the big data. The cumulative number of publications indexed by Google Scholar is another evidence of this phenomenon. Essentially, big data in healthcare refers to large and complex electronic data sets generated around patient care. There are two main types of data in healthcare: structured data, which includes diagnosis codes, laboratory test results, etc., and unstructured data, which is mostly comprised of free text documents. Structured data have a predefined model of data and are often numerical in value. Billing codes, blood pressure values recorded in a patient's chart, and some test results are examples of structured EHR data. This category of data has a high degree of organization, making its inclusion into relational databases seamless, and it's also easily searched and is amenable to automation for various downstream analyses. However, unstructured data constitutes 80% of the data in EHR, and unlike structured data, this category of data has lots of free text in it, as shown in the sample history of presenting illness in the slide. Unstructured data is information rich, but does not yield itself to automation with traditional analytical methods, typically requiring laborious human effort, thus compromising the vision of a learning healthcare system. And that brings us to the question, how do we structure the unstructured data to achieve the goal of a learning healthcare system? Some approaches that have been tried in the past in this regard have met with limited success. One of them is using ICD-10 diagnosis codes in detecting a medical condition. However, this has been shown to be very inconsistent in its accuracy. Keyword searches within the electronic health record is another approach, but it works well only if the terms being searched are infrequently used, like rare diagnoses. Structured entry systems, such as the ones shown at the bottom of the slide, are documentation templates developed to structure the clinical narrative right at the point of documentation. Instead of free text, these systems offer a drop-down menu with terms conforming to syntactic and semantic standards. However, the uptake of this method has been limited in the clinical world since it slows down the clinician's workflow, and this method does not capture the nuances that a clinical narrative provides. Let's now look at natural language processing as a possible solution to this problem. Natural language processing is defined as a field of computer science artificial intelligence, and linguistics concerned with the interactions between computers and human languages. In other words, it is a science that enables computers to derive meaning from human language. Let's look at some of the basic natural language processing methods. Regular expressions is a basic NLP method and has been popularly described as a keyword search on anabolic steroids. In principle, this method is comprised of a set of search rules which combines alphanumeric characters such as the word reading in this example with meta characters such as asterisks and parentheses to stem the word to its root, read in this case, thus increasing the specificity by removing false positives from the search results. Another basic NLP method is document classifier. In this method, the researcher feeds in two sets of sample documents into the program. For example, if the researcher were to be looking for patients who had seizure, the first set of documents would be obtained from chart of a patient who actually had a seizure, and the second set of documents would be obtained from a patient who did not have a seizure. The program, after being fed with these two classes of sample documents, undergoes machine learning and is now ready to process a test document as seen in this diagram. It first gets rid of some common words and numbers from the English language and then stems the words to come out with what is called a bag of words. It then plots the bag of words on a graph and uses a dimensional vector to classify the data into positives and negatives. Basic NLP methods like these can be used by clinicians who have no formal training in computer science. In contrast, the advanced NLP methods can be built only by highly skilled analysts. Let's look at some examples which we use in daily life. Information retrieval is an advanced NLP method which develops algorithms for retrieving documents from a given repository. Search engines such as Google and Yahoo are a good example for this method. The second technique here, the question and answer method, is an information retrieval system at a much finer level, usually at the level of a sentence or a paragraph. Sentiment analysis is another NLP method that determines if a piece of writing is positive, negative, or neutral in emotion. This technique currently finds application in online customer reviews. Information extraction is an advanced NLP technique that holds the promise of helping solve the problem of structuring the unstructured EHR data. This technique identifies keywords in a narrative as shown by the words in red in this example, using a number of other techniques such as parsing, stemming, etc., and then maps the keywords which are obtained onto a predefined data set such as SNOMED. Medley, CA ties, and CTAKes are all successful examples of this technique. The last technique we will review is called the patient cohort identification. Without going too much into the details, this technique automatically converts the complex textual eligibility criteria listed in studies into a computable format to screen a database such as electronic health records to identify patients eligible for a trial with minimal or no human intervention. Limitations to NLP use in healthcare remain time, money, and the multidisciplinary expertise that is needed to accurately design an institution-specific NLP algorithm. The other concern is that the domain of patient privacy hasn't been studied in the NLP studies. In summary, information embedded within the unstructured EHR data can be extracted with an array of readily available NLP methods with good accuracy rates. The unlocking of unstructured clinical data has great potential for increasing the value in healthcare, thus realizing the vision of a learning healthcare system. Disruptive innovations to make NLP affordable and further high-end research may eventually facilitate NLP use in healthcare. Thank you.